We're going to work on the data layer for our Minutes app. Here we're going to code a class called MemoryEntryStore. We're going to store our entries in memory, and we're going to use a dictionary behind the scenes to hold the objects, which means we're going to be able to write this entire class in our shared code. Again, our goal is to store this collection right here of entry objects. We already have an interface defined that lists the operations that we need to support. So read, write, and delete. Our goal here is to write a class that implements that interface. The interface follows the async pattern. So we have async on the method names, and these all return tasks. In our implementation here, since we're storing things in a dictionary in memory, we're not actually going to need any async APIs. So there's going to be a little code to adapt our use of the dictionary to this async pattern. But again, with this interface, we're preparing for the future if we want to store our entries on disk or in the cloud, in which case the async pattern would be considered best practice. We're going to add the MemoryEntryStore class to our shared code project here. This class needs to implement the iEntryStore interface, and Visual Studio will stub that out for me. There's two parts to this implementation. First is just doing the storage in a dictionary, and second is adapting to the task async pattern. Let's do the dictionary first. We're going to use the ID as the key in the dictionary, which is a string, and then the value will be the entry object itself. Let me do the write operation first. We can use the indexer. Again, use the ID as the key and the entry object as the value. And this will work whether we're adding a new entry to the dictionary or replacing an existing one. And delete is pretty simple as well. Entries dot remove, pass in the key. And the read method, this is read all values, read the collection of entries in the dictionary. And the dictionary has a values collection, and if I hover over that, it is of type value collection, which is not a list. So I'm going to use the toList extension method. Let me go up to the top here. That we get from system.link to convert from a value collection into a list. So that's the first part. That's the use a dictionary to store the values. The second part is adapt this to the task pattern. All these methods here are synchronous. So at the point at which these complete, the task is done. The task is completed. There's no pending work still to do. So for delete and write, I can finish these methods really simply. I could just say return task.completedTask. So copy that and paste it down here because those two are the same. Read is just a little bit more tricky because we have to return a value as part of the task. And again, we have a nice static utility inside the task class to do this for us. So return task.fromResult, and we pass in the result there. And that's going to create a completed task object for us and send it back to the client code. And that's it. That's the entire implementation of MemoryEntryStore. Now that we have MemoryEntryStore, we should create some mock data to use for testing. And I'm going to do this with an extension method. And I'll be very literal in my naming. Mock data extension methods for the class name. And this has to be a static class. And it's going to be an extension method. So it'll look like that. On my clipboard here, I have 3 entry objects ready to go. And all I need to do is load those into the store parameter here. The only tricky thing is that the store methods are all async. So I can just wait for them here so they run synchronously. And that's it. Then I want to go create an entry store object in my app class. So here's my app class. I'm going to go to the code behind file, app.xaml.cs, and I'm going to add a property here that I'll call entries. And then here in my constructor, I can create my memory entry store object. Load mock data. So now we have a memory entry store object created and initialized with some sample data for testing.